Hey, welcome back to Mr. P Helps with Algebra. This is Unit 2, Topic 2, Lesson 14. This is a lesson about exponential growth versus decay. Here we go. So we have a warm-up which has a linear equation and two exponential equations, and we're going to complete the table. So we've got negative 3 times 17, which is negative 51, and if we add 28 to that, we get negative 23. So using a calculator, so we got 17 times 1 is 17, and 17 added to 28 gives us 45. 4 times 17 is 68. Add that to 28 is going to give us 96. 5 times 17 is 85, plus the 28 is 113. Okay. There is a pattern here. The pattern is adding 17, but the reason why I'm not just adding 17 constantly over here is because the intervals aren't necessarily going by equal intervals. So this jumps from negative 3 to 1, and then 1 to 4. That's an increase of 3, and that's an increase of only 1. So there is no common interval change right there. So you've got to do each one separate. This one's going to be a little bit easier. Well, I'm going to start right here with the 0th power. Anything to the 0th power is 1. 10 to the 2nd power would be 10 times 10, which is 100. And 10 to the 6th power is going to be a 1 with 6 zeros, which ends up being a million. Now, when I go to the negatives, so 10 to the negative first is 1/10. If 10 to the positive 1 is 10, 10 to the negative first is 1/10. 10 to the third would be 1,000, so 10 to the negative third would be 1,000th. Because 10 to the negative second would be 100th. Here we go, so we got 1/5. Once again, the easiest one would be 0. Anything to the 0th power is 1. 1/5 to the 3rd power, well, 1 to the 3rd power, because you have to do whatever's exponent is, you have to do both the top and the bottom to that number. 1 to the anything power is still going to be 1, because 1 times itself, no matter how many times, it's still going to be 1. 5 to the 3rd power, 5 times 5 is 25, times 5 again is 125. So this is 1 over 125. And I need to pull up my calculator again, because I'm going to do 5 to the 5th power. So that's 125, which is to the 3rd power, times 5 again is 625, times 5 again is 3, well, I lost it, so 3,000, oh, okay, 125 times 5 again is 625, times 5 one more time is 3,125. All right, 1 over 3,125. Okay, so now when it's a negative exponent, this time it's going to be flipping it. So this is really like 5 over 1 to the 2nd power. Because since it's a negative exponent, what you do is you do the reciprocal. You flip it to the opposite. So you take the numerator, put it on the bottom, put the denominator on the top. Well, 1 to the 2nd power is still 1. 5 to the 2nd power is 25. To the 4th power, which I believe that was 625. 5 times 5 is 25, times 5 is 125, times 5 was 625. All right, so once again, I'm going to get into the lesson. The lesson is about exponential growth versus decay. So we've got two real-world problems here. So this one's about Mama Big Bucks putting $20,000. Ooh, that's a lot of money. I guess that's why they call her Big Bucks. So she puts that money into a bank savings account, and she's getting paid 3% interest. I'm going to jump straight to the equation. So that's 20,000 is the starting point, multiplied by a rate of 3%. Now, anything times 1 means stays the same. So in this case, you're going to be paid money, which means this is going to be an increase. We call that exponential growth. And the reason why it's growth, because growth means to get bigger. So this is 3% more than staying the same. Well, 3% is 3/100ths. If we multiply that by 1.03 X amount of times. 1.03 is a 3% growth because that's 3% more than staying the same. And anything times 1 means the same. So all I have to do to make a table is choose what x's I want to use. So 0, 1, and 2. I can choose anything I want. 20,000 times 1.03 to the 0th power and to the 0th power is 1. Well, obviously, if you put it in for 0 years, which I believe X was the amount of years, I might have to go back and look. I'm just going to have to assume, because I don't see it right now off the top of my head. So I'm just going to assume it's per year, so that's $20,000 because nothing's changed. 1.03 times 20,000, so I got 20,000 times 1.03 equals 20,600. Do that again, times 1.03, and you've got 21,218. So the pattern is times 1.03, 1.03, 1.03. It's a geometric pattern because it's an exponential function. So I could then go ahead and graph that. So I'm going to make a one quadrant graph. So this would be 0, this would be 1, this is be 2. And then I would start here at 20,000. I'm going to make a broken graph because I have no need to put 0 through 200. So I've got that little lightning bolt, which usually you put right there, which shows that it's a broken graph. So that's 20,000. This would be 21,000. And it's not writing too well here. And this, we could call this 22,000. Yeah, once again. So there's 20,000, then 2,600, and then 21,215. Let's say it's about right there. So yeah, it is curving. It's a little bit hard to see, but it is going to be curving up because it is exponential growth. All right. Part of the reason why it doesn't look like it's going up so fast is because I did that broken bar graph, so it's zoomed in so much, it doesn't really look like it's curving, but it is, ever so slightly. Plus, I didn't do a very good job spreading out my intervals. It wasn't pretty messy. All right, so this one is, so this shows you the formula for exponential growth, 1 plus the rate to the power of t. So you always add the rate when it's growth, and you always subtract the rate when it is decay. All right, so this is kind of the same thing as we just done. So I'm going to skip this and go to the next question. So now we've got what's called depreciation. That means decay. That means it's getting smaller. So she buys a car for $20,000 and it depreciates. So the original cost of the car was $20,000. Multiplied it by 3% decrease. Now, if times 1 means staying the same, so 100% is the same thing as 1. A 3% decrease would be like 97% because that's 3% less than 100%. So that's actually 0.97 is the rate. So whenever you're doing depreciation, you subtract the percentage from 100%. So that makes it quite different. So I would go through the exact same thing so I can set up my table. If it's gone 0 years, it would stay the same, so it would still be 20,000. And then just keep multiplying 20,000 times 0.97 with your calculator. And then graph it just the same as I did before. All right, so I'm going to skip through this since I've talked about exponential growth and decay. Growth meaning adding to 1, and decay meaning subtracted from 1. So look what we got here. We got question number 4. Find the simple interest if you pay on a 5-year loan $7,000 at 11% per year. So that's going to be 7,000 times 1.11 because that's an exponential growth. Then multiply that by 5. We're talking about simple interest. I'm sorry. What are we talking about? We're not talking about exponential growth. This is simple interest. I'm sorry. 7,000. Try that again. Times 0.11. And then multiply that by 5 years means you'll have to pay $3,850 of interest. And then you can say, well, you add that to the original loan amount, means you're going to have to pay a grand total of $10,850. But that's how much interest you're going to have to pay. How much interest do we have to pay for 2 years on a loan of $1,500? So that's $1,500. That's I equals PRT, so that's the principal, times the rate, which is 0.045, 4.5%. Move the decimal twice to the left, makes 0.045. And then you multiply that by a 2-year loan, is $135. Okay, so this one, number 6. I'll do the exact same process because I'm searching for I. So that's 11,275 times a rate of 0.12 times 3 years means you end up paying $4,059. Now, if you look at the other two questions, they are a little bit different, so I'm going to erase all of this because now you're trying to solve for how much time. So what I would do for each one of these questions down here, 7, 8, 9, is set it up like an equation. So if we know the answer is 1428 equals 5,100 times 0.04 times some amount of time. So there we go. So if I want to solve for the amount of time, I'm just going to divide 1428 divided by 5,100. That gives me 0.28, and then divide that by 0.04, and that gives me 7. So 7 must be the amount of years. Okay, so I'm going to erase that again. Set up the next one. Number 8, $93.75 equals 1250 times something, which is the rate, times 6 months, which is the same as half a year. So that's half. So here we go. 93.75 divided by 1250, and then divide that by 0.5, which means the rate must have been 15%, because I got in my calculator 0.15 as the answer. So that's 15%. Last question, last time I'm erasing. So we've got $54 equals some principal, we don't know how much money, times 0.08, 8% rate, times 9 months. Well, 9 out of 12 is the same as 3/4, which is the same as 0.75. All right, so now I'm ready. So I've got 54 divided by 0.08 and divide that by 0.75. That's 3/4 of a year. So that means it must have been a $900. That's what my calculator says. $900 is how much you borrowed. All right, thanks again for watching. I know I went up to about 12 minutes. Please give it a like if I helped you learn something, and subscribe if you haven't done so already. Thanks for watching. Have a great day.